Alright, today let's go ahead and get started with Stoichiometry 5. Stoichiometry 5 is theoretical yield and percent yield. Now, again, this is one of those where you can kind of look at the words and get an idea of what we're going to do with them. Theoretical means in theory, right? So what we think might happen. The theoretical yield is what we calculate in a Stoic problem. So we can calculate it, but that's not always what happens in the real world. Okay? And that's where percent yield comes in. Percent yield is what part of your theory that you actually got. So what part you really got. Okay, you can tell, I mean, it says percent, so just like a grade, we all want to get 100%. Your teachers think they teach you 100% of it, but what you actually get on the test is sort of that real life amount, Okay, so theoretical yield, we are doing the same thing, nothing new. Okay, percent yield, we've already done some percent problems, but for percent yield, we're going to say percent yield equals actual amount that you get out of the experiment over theoretical amount. So actual over theoretical times 100. So kind of just like a grade in a class. How many points you actually got on the test over how many points were available times 100. Okay, so this concept isn't a super new concept, but it is new and applied to when you apply it to these stoichiometry problems. So let's do an example and try to get as much work time in as we possibly can. Okay. Your example. How many grams of silver are produced when 50.0 grams of copper react with 0.750 moles of silver nitrate. Okay, so this does not look anything different than any of the other problems that you have done thus far in stoichiometry. So we're going to start out exactly the same. We're going to have a balanced chemical equation. And so with that, we look at our problem. How many grams of silver are produced? So we know that silver is going to be a product. When copper reacts, so copper is going to react with silver nitrate. All right, so is this even a completed skeleton equation? No, because we just have silver as a product. If we look at this, we know it's a single replacement reaction because we have one element and a compound. So this element is going to take the place of one of these two pieces. In this case, we have a metal. It's going to make a positive cation. It's going to take the place of the metal, the positive cation. And that's convenient because we were told silver, and we know that that means the copper and the nitrate are going to have to come together. And that's all that's left in our equation. Now, we need to know, how is copper going to come together? How is that going to make a compound? Well, we know that copper can make two different cations, so we are going to go with the most common one. We're going to say it is copper 2, since we are not given. And this could be a point of error as well. If you just assume which ion it is, that could be a point of error, but we will meet that when we get there. And we know that nitrate has a -1, so we're going to crisscross those. We need the parentheses. I'll put 2 there. Okay. So now we balance it. We see that we need 2 nitrates. Those polyatomics can stick together. So we need 2 over here. 1 copper, 1 copper. We need 2 silvers. Okay, now we have a balanced chemical equation that does make sense. Okay. And so we can go ahead and do our stoichiometry. We had 50 grams of copper. How many grams of silver are produced? Okay. So how many grams of silver are produced when 50 grams of copper react with 0.75 moles of silver nitrate? Wait a minute. What? We're given 2 reactants here. So in this problem, when we're given 2 reactants, we're going to have to figure out what's the limiting reactant and find out how much silver could we come up with. So we're going to have to do a little bit longer of a problem here. We're going to start with copper since it's the first one we have. And we're going to just do stoichiometry. Okay? And if I look at my periodic table, I'm going to find that copper has a molar mass of 63.5. And I need to get rid of my moles of copper. And in this case, I'm going to come up with moles of silver. That's really what I'm looking for. And my question does ask me for grams. So I need to go one more step. Okay. So here's my mole to mole ratio. In my balanced chemical equation, I have a coefficient of 1 on copper and a coefficient of 2 on silver. I'm going to come back to my periodic table to find the mass of silver. 107.86, so 107.9. Alright, so calculate that out. So we got 50 times 2 times 107.9 equals equals 10,790. And then I'm going to divide by 63.5 because those are just ones. Okay, I get 169.9. In that scenario. Okay. Now I have to do for this reactant because it might be the limiting reactant. Okay. So we'll have to look at that. Now luckily we start with moles, so we don't have to find the molar mass of this. We can go straight to the mole to mole ratio. So this is not any different than the stoichiometry that we've already done. And in this case we have a 2 and a 2, which will cancel themselves out. But we did ask for grams, so we might as well go ahead to grams so that we can compare accurately. And we already looked up that number, we can use the same one. Now, I can acknowledge that my 2 cancels there. And so I really just have to multiply 0.75 times 107.9. Sorry. So it should be 80.925 grams of silver. So then we say, okay, this silver nitrate was the limiting reactant. So this is the amount that I can use. My question asked me how many grams of silver are produced when I do this. So I can only get 80.925 grams of silver. That right there is theoretical yield. Okay, so that is theoretical yield. How much you think you can get from your calculations. Okay, so we really just put a label on it. Now, what happens if we do this in the laboratory and you only get, so we'll say in the lab, you only got 76.0 grams of silver. That is your actual yield. So what do I need to do to find percent yield? Let's go back and look at our notes. If we look, percent yield was actual over theoretical times 100. So the percent yield for this lab so actual over theoretical times 100. So 76 over 80.925 times 100 gets us 93.9%. So that is a pretty good percent yield. If that were our score, we'd be happy. If that's what we actually got out of the lab, that would be happy. Alright, give me a thumbs up if that makes sense. Okay, this is probably the easiest part of stoichiometry, really, because you've already done all these hard things, and then we're just putting a label on it, and we're finding out what our percent yield. This is really the only new thing, is percent yield for today. Alright, so 31. Okay, so we're going to start doing these practice problems from the work in the lesson. I'll just do these on the screen as well. If given the following equation, aluminum sulfate plus sodium hydroxide yields sodium sulfate and aluminum hydroxide. If you start with 389.4 grams of aluminum sulfide and you isolate 212.4 grams, what is your percent yield? Okay. So first things first, always write down your chemical equation. That gives you an example. It lets you know what you're working with. And that way when you're using your notebook on a test, hint, hint, you can be able to see what you did. Just make sure you write it down correctly. Okay, so there's our problem. It says we start with 389.4 grams of this. And we isolate 212.4 grams of sodium sulfate. Now this is a question, because we know earlier we talked about actual versus theoretical. If this is what we got, actual yield, what is our theoretical? So we have to calculate our theoretical in order to be able to find percent yield. So we're going to start with what we know. And we have to go grams to moles because we can only compare moles. And then we want moles of this stuff. Al2, SO3, 2 moles of the other stuff, moles of the second thing. So if we look, we had a 1 with aluminum sulfate. We had a 3 with sodium sulfate. Now here we need to calculate. So we have aluminum, we have sulfur, we have oxygen. I have 2 aluminums, I have 3 sulfurs, I have 9 oxygen. I'm going to go to the periodic table and find what is the mass of aluminum. So it's 27.0. And sulfur is 32.1. So we go back and find sulfur, 32.1. Yeah. And I've already calculated these out, so I can do this a little quicker. Okay, so look at our problem. Grams of aluminum sulfate cancel, moles of aluminum sulfate cancel. We're given grams in our actual yield. So in order to do our theoretical yield, we have to go to grams of that as well. So let's calculate that. We have 2 sodiums, we have 1 sulfur, 3 oxygens. We'll go to our periodic table and find that sodium is 23.0. Okay. So our theoretical yield would be, so you go straight across the bottom, and we divide it all out. Our theoretical yield is, that's not going to fit there, 500.5 grams of the sodium sulfate. Now wait a second. If our theoretical yield is 500.5 grams, and we only got 212, we didn't do so hot on that one. And we're not done with this problem either. We still have to calculate percent yield, because that was our actual question. These are very long problems, okay? So let's come down here and we'll do percent yield. So actual over theoretical times 100. So the actual in the problem was 212.4. The theoretical was 500 times 100. So when you calculate that out, it's 42.4. What did you say, Caden? Do you have a question? Okay. Alright. So these are super long problems. But it is what they are. Okay. So if you want to have the worksheet open, that would be good, and then I'll just go ahead and keep working them. If you're fine and you know what you're doing, go on your own pace. I'm going to work another problem, and then I'll give you some time without me talking to work on some, okay? So let's look at number 2. It says, given the following equation, we're doing the same thing. We're going to start with an equation from the worksheet. It says aluminum hydroxide. And these are great because they already give you the balanced chemical equation. They don't make you balance it. Okay, so it says if you start with 53 grams of aluminum hydroxide, so 50.3. And you isolate 39.5 grams of aluminum chloride. What is the percent yield? So this is our question. This is our actual number right here. Alright, well I have to find the theoretical first. So still gonna go that direction. And we're gonna lay out our stoichiometry. Kind of getting in a bad habit here of not writing all my units, but we want to keep in the habit of writing our unit. We'll come back and do that. Molar mass here in just a second. Now we're ready for our stoichiometry, the mole to mole ratio. Conveniently, they're both 1, so that's nice. So we have 2 molar masses we have to calculate here. I have aluminum, oxygen, and hydrogen in this one. We just have 1 aluminum. We have 3 oxygen, 3 hydrogen. We know oxygen. We know hydrogen. Aluminum. 27.0. Add them all together. Okay. That's one. Now we got to do this other one over here. Aluminum and chlorine. Aluminum, we have 27. There's only one of those. Chlorine, there are 3, and it is 35.5. You might be saying, where'd you get that from? I have my handy periodic table right here. 35.5. And I can't do 3 times 35.5 in my head. 106. Okay, so then we go straight across the top, straight across the bottom. Conveniently, the bottom is just going to be divided by 78. So I am not going to try to squish that in over here. I'm just going to come down here. And I know that my problem is going to have a 78 on the bottom. So we have to go 50.3 times 1 times 1 times 133.5 is this ridiculous number. Okay, that is my theoretical. Yield. Okay? But that's not what the question says. The question says, what is the percent yield? Yeesh. Okay. So our actual, what we got from the problem was 39.5. So the problem said you isolated 39.5 grams of the the aluminum chloride. But your theoretical, what you should have been able to get was 86.1 grams. Then times 100. So when you plug that into your calculator, 39.5 divided by 86.1 times 100 gives us 'So that is the actual answer. Yeesh. Okay. You have like 6 minutes left. It took us 6 minutes to do this one. So if you go ahead and do, this was number 2, go ahead and do number 3 and we'll call it even, okay? Just do one problem. That'll give you, that way you don't have homework, because I know CK12 is still looming out there. Okay, but do number 3 and then we'll come back and maybe use this as a review later in the week. Okay.